The theory of computation or computability theory studies which functions could be effectively calculated. Mathematically, computability theory wants to study the notion of algorithm. In logic, computability theory is essential to understand constructive mathematics, and it provides the tools to pursue limiting results. It makes sense to calculate a function from naturals to naturals when it can be described in such a way that its description is formal and finite, it operates on a finitely generated language, it takes a finite amount of time to terminate. Having a formal description which can be really used implies the description to be written in a finite alphabet. So the procedures are a subset of the finite strings on that alphabet. Hence, they are at most Aleph 0. Since each constant function in N is obviously computable, the procedures are exactly Aleph 0. However, the set of functions from N to N are 2 up to Aleph 0, which is strictly greater. So most functions are not computable. Among the many equivalent ways to define computable functions, we choose partial recursive functions. We use partial functions to permit computable functions not to terminate on every input. We prefer a more mathematical approach that directly describes a family of functions rather than abstract machines like Turing's implementing them. Although it is not immediately clear, this approach simplifies applications in logic.